Hi, this is Kai from Raising the Bar, and this time it is about exercise 2.4. In fact, I want to do a little more. I want to show how in Excel you can construct the density and distribution function of a normal variable. Everywhere in this example, I'm going to use as the mean of a normal variable this number, 25, and as standard deviation, sigma, this number, 5. And I'm doing this in order to be able to model the temperature distribution in summer in my city, which is Almaty. Okay, so here I want to generate a range of temperatures, and probably it should be something like from 15 to high temperatures like 37. So I'm introducing the first two temperatures, and this is in Celsius. Okay, and then we automatically generate the other temperatures, 35, 36, and 37. Perhaps sometimes you can see even 38 in Almaty. These are the temperatures, and here the first function that I want to insert will be a density. And in order to do that, we go to functions, okay, and then here among the categories you select statistical, and then in the lower window go down, and you can see that there are 4 functions related to normal distributions. We can use the first two because the other two are special cases of this first two. Now I'm going to use normal dist, the function which is called normal.dist, and it returns the normal distribution for the specified mean and standard deviation, and actually it has two sub-functions. Okay, so for the argument, for the argument I enter this value for the temperature. Okay, this should change. For the mean I enter this value in cell B1, and this should not change, therefore I am pressing F4. For the standard deviation we use this number 5, and also this should not change. And then in the last choice we have to show, in the last option would be for the cumulative or density. If you want, it is written here, if you want a density function you say false. This is a logical argument, false. Okay, then we say okay, and I see here that this is the density of the normal distribution with these parameters 25 and 5 at temperature 14. Okay, and then we can copy this down, and then we get a range of values of the density for the specified temperatures. And we can see, if I click on the heading of this column F and then go to insert, and I want to see how this looks on the chart. Okay, this would how it would look, and you can see that the values on the horizontal axis are wrong. Actually, we need to edit this graph, and I'm not going to do it right here, but you can see that the highest values are in the middle of that range, and the values which are close to the boundary, 14 or 38, they are not very likely. Okay, so let me skip this chart. I'm not going to show it. Once again, this was a chart for the density. Next, I want to see the cumulative distribution function. Okay, cumulative distribution. In this case, we use the same function with a different argument. Okay, this will be normal distribution. Okay, and as the argument, as the temperature, we take again this one. For the mean we use the same as before, 25, and I press F4 to make it fixed. For the standard deviation, we use this number 5. Again, press 4 to make it fixed. And the last option, instead of false that we entered before, we use true. So it will be cumulative distribution. Okay. Then we copy this down. Okay, and we can see that the first values are very close to 0 and the last values are very close to 1. And then we can see what happens on the chart. Like, see, this is the usual shape of a cumulative distribution. Okay, again, I'm not going to do that. I want to proceed with generation of random numbers from this distribution. I want to generate a sample of possible values for the temperature. For this purpose, we use something different. Again, go to statistical category and among the functions choose this one, normal inverse. Okay, and actually this will be the inverse of the cumulative distribution that we constructed in the second step. Okay, and then the probability would be that the random number generated that we studied earlier, random, and this is very important, that the uniform distribution over the segment 0, 1 can be used in this construction in order to generate random numbers from a normal variable, from a normal distribution. For the mean, we use the same number, 25. For the standard deviation, again, the same number as before, 5, F4, and then click OK. So here you can see that when we measure temperature, usually we are not concerned with the decimal places. So I want to make this integer number. In order to do that, we go to Format Cells, Number, and I want no decimal places, 0 decimal places. Okay. So this is one of the random temperatures that we generate using that function, and then we copy this down. Okay, and there will be many random temperatures. So here I am saying this is a sample. This is a sample, and next I would like to see at the I would like to see the histogram for this distribution. And if you remember from the last exercise, in order to construct a histogram, we need bins. Bins divide the observed sample into groups. The lower value for the bins should be 14, because this is the way I started the whole example. And the other values can be chosen arbitrarily, and I want them to form an arithmetic sequence with the step 3, for example. So this will be the first value is 14, the next one is 14 plus 3, and the rest of them will be generated the same way until we get to 38. Here I get 38. So we have the bins. These are the intervals in which those observed random values will be distributed. And once we have the sample and the bins, we can go ahead with construction of the histogram. And to do that, we go to Data, and there is on the Data tab, there is Data Analysis, and you know how to do that. In Options, you have to choose to load this the Analysis Toolpack. So I click here, and then histogram has already been chosen. So I click OK. Okay, and then for the input range, we choose the random numbers that we generated here. for the input range. For the bin range, we select the bins that have been chosen here. For the output range, the first cell of the output, could be here, doesn't matter much. And I also want to see the chart output. So this I checked, put a check mark here, okay? And then we can click OK, and here you can see the outcome. From this histogram, we see that the value 29, temperature 29, is the mode, it's the most frequent observation. 14 has never occurred, and so on. Thank you. See you next time.